Very good morning, all of you. Okay, in today's lecture, we'll solve the given numerical. Okay, in this numerical, you have given ruler type of the support. We have seen the different types of the supports, right? Here, you have given the ruler type of support. Also, you have given here that pattern type of the load. If the pattern type of load is given in the loading diagram, then how to convert that load into the point load as well as into the moment, or we can say the couple. Okay, very important. You know the cycle pattern. When you apply the force on that cycle pattern, this force is going downward direction as well as they are rotating in clockwise or anti-clockwise direction. That's why we will get the couple at that point. Okay, means if you have given the pattern type of the load, then there is a at that point load is act as well as couple will act. And how to act this couple at point C in today's lecture? We will see the details. Okay. First, see, you are given the roller type of the support. We have seen and how to act roller type of the support having the two reaction. One is the vertical reaction and another is the horizontal reaction. Okay, reaction. Then how to convert that into the vertical and horizontal? I will again draw the loading diagram. See, this load will convert into the the trigonometry. Here is a 30 degree, 60 degree, and here is a 90 degree. We want to convert into the 90 degree. Then what you will get? RA sin 60 is there, and horizontally here is a RA what cos 60 is there. RA sin 60 and horizontally you will get the RA cos 60. Then next this UDL is at as it is on the given beam, right? Up to the last. There is a one more support, base support fix. Okay, this always act to the normal to the base of that given surface. The distance is given 2.6 meters. See, when you convert that 2 kilonewton, actually 2 kilonewton is at the C point, right? At the C point, this 2 kilonewton is at in downward direction at the point C. Okay. Then again see how to convert this load is going in anti-clockwise direction. Check that. We are applying this load at the point C in this is going anti-clockwise direction. This how to convert this? What is the couple force into distance, or what is the moment force into distance? 2 into this horizontal distance. 2 into horizontal distance 0.9 means here is a couple is at here in this way at the point C. Again here you will get this value 1.8 kilonewton meter. Okay, all of you getting 1.8 kilonewton meter. This couple is acting anti-clockwise direction. If you have this distance is given this side, okay, 0.9, then this point load is going clockwise direction. Okay, remember that. Then see the total distance. Here at the C point, here is a 0.9 is given. Means 2.6 plus 0.9, you will get the total distance. This distance is a 3 point what 965 is there, right? And this one from the point C is 1.7 is there. 1.7 meter. Okay, all of you getting how to convert that given point load or pattern type of load into the moment, as well as this roller support is converted into the reaction RA sin 60 and RA cos 60. Okay, remember that first you have to convert this given diagram into the point load and moment, as well as again this support also convert into the point load. This is the 2.5 kilonewton per meter. Then how to calculate the reaction? First point, you know the support reaction. Support reaction. Yes, summation of Fy is equal to 0. We will consider the vertical positive. Okay. Then see how many vertical forces is that. Ra sin 60 is upward direction, means positive. This as it is, we don't know what is the value of Ra. What is the value of sin 60? Root 3 by 2. Root 3 by 2. All of you know this. Then there is a one more downward force is at 2 kilonewton. Means minus 2 is there. Minus 2 is there. And here is a one more force is acting in upward direction. This one plus RB is there. Then check that there is a UDL is given from A point to the B point. Okay, we will give the name A to B. UDL is given. Okay, then you have to convert it to the point load again. They are acting in the downward direction. 2.5 into the total load. 2.5 into the total. What is the total distance is given? There is a 5.2 is there. Okay, I will write minus 2.5 into this total 3.5 plus 1.7. Means how much you will get the, well, 5.2 is there. 5.2 is there. It is equal to 0. But here you will get the two constants. Okay, that's why we don't get the value with the help of that summation of Fy, Ra or Rb. Then what we will do? We will take the moment at point A is equal to 0. Summation of the moment at point A is equal to 0. We will consider the clockwise positive. Okay, then check that we will take the moment at point A is equal to 0. Then this one 0. I will take this one 2 kilonewton. This is going again. Check that we are going. Okay, clockwise direction. 2 into this distance. 2 into this total distance 3.5. 2 into 3.5 is there. 2 into 3.5 is there. And again here is a couple is that in that anti-clockwise direction. Already they are converted to the couple. That's why don't multiply by this distance. Keep as it is 1.8. 1.8. Okay. Then check that. Here is a RB minus. This is going anti-clockwise. Minus RB into what? Total distance 5.2 is there. And again there is a one more force is at UDL. This is again in which direction? This force is going clockwise direction. That's why positive. Plus what? 2.5. Where is that? This total distance is at 5.2 is there. Right? 5.2. Again into where is the CG? 5.2 divided by 2 is there. Is equal to 0. We will check that 3.5 into 2. You will get the RB is equal to what? You will get RB. Here is only one constant. Check that. RB is the constant. You will get the RB value is equal to 7.5 kilonewton. RB is equal to what? 7.5 kilonewton. Okay, put this value in that equation. If you are putting this value in that equation, then you will get the Ra into sin 60 is equal to, minus 2, again plus RB 7.5 kilonewton, minus 2.5 into 5.2 is equal to 0. Then you will get the Ra value. If you find out the Ra value, then you will get the 8.66 kilonewton. Okay, and if you want to find out this Ra sin 60 is equal to what? Sin 60 root 3 by 2. Then you will get the again Ra sin 60 is equal to, I will check that, Ra sin 60, you will get the 7.5 kilonewton. Again, you will get the 7.5 kilonewton. Ra is equal to 7 point, Ra sin 60 is equal to 7.5 kilonewton. Both value will get the same. Okay, all of you getting how to calculate? Once you have calculate, see, once you have calculate, then you can draw easily the SSB. How to draw the SSB? Already I have told A is there, C, and B point is there, 0 line. From A, check that Ra sin 60. Here don't miss sin 60. Some students are taking only the Ra value, means 8.66. This is wrong because we are converted into the Ra sin 60. Ra sin 60 value is 7.5 kilonewton is there. We are going upward direction. This 7.5 kilonewton is there. In between A to C, check that there is any load. Yes, there is a UDL is there. This is the 2.5. 2.5 is there, right? Means you will get the in downward direction 2.5 into 3.5. Okay, 2.5 into 3.5 is there. Okay, means you will get the minus 1.25. Okay, if you are doing the calculations, check that I will do the calculation first. Then you can easily understand what is the given actually and what we will get. Check that. I will write the SF calculations. SF calculations. Okay, what is the SF calculations? SF at A, just left side, you will get the 0. SF at just right side of that A, we have the Ra sin 60. Right? SF at A, just right side, we have the Ra sin 60. What is the value of Ra sin 60? 7.5 kilonewton. Then next point, SF at C. Okay, SF at C point. Next point is SF at C, just left side. Check that SF at C point, just left side is there. What is the value of Ra sin 60? Directly I will write here 7.5, right? Because this is acting upward direction and downward direction, how much force is that? Minus 2.5 into this distance 3.5 up to the C point 3.5. You will get the minus 1.25 kilonewton. Okay, if you have calculated, then you will get the SF at C minus 1.25 kilonewton. Then similar way you have to calculate the SF at C just right side. Just right side. We are coming just right side of this. Okay, you will get which value? Check that. We will check. We will consider again here is a minus 2 kilonewton load is that, right? Up to the C we have calculated the left side. Only you will get the minus 2.5 into 3.5. Then again here, if you are coming just right side, then there is a 2 kilonewton load is there in downward direction. That's why minus 2. Okay, means minus 1.25 minus 2. You will get the minus 3.25 kilonewton. Yes, all of you getting? Then SF at B point, just left side, you will get whole value. Check that. Ra sin 16 again 7.5. Then minus this, I will consider this one 2.5 UDL into what is the total distance from A to B. This 5.2 is there, right? Then again minus 2 is that, minus 2. This value you will get minus 7.5 kilonewton. And if you have calculated SF at B, just right side, check that. Up to that left side we have the minus 7.5 kilonewton, right? And how much load is that? Just right side, we have considered the RB value. RB is equal to what? Plus 7.5. You will get the 0. Means first and last point, always you will get the 0 value. Remember that. Then we will draw the SFB 7.5 kilonewton at just left right side. SF at C, we have the minus 1.25. See, A to C, you have given the UDL. Then we will draw the inclined line. But we have the minus value. That's why we are coming downward from that zero line. Okay, or below the zero line. Means this one will get, I will draw here. Suppose here is a 1.25 kilometer. 1.25 kilometer. At the same point here is a 2 kilonewton is there. 2 kilonewton is there. Except at C right side, we have the value minus 3.25. Means we are coming on the same line again downward. 3. What is the value? 3.25 kilonewton. Okay. Then again there is a UDL is there in between C to B. Check that. Except at B point left side minus 7.5 kilonewton. Suppose here is a 7.5 kilonewton. Okay, minus, because we are coming the downward. Again you have to draw the inclined line because of UDL is given. Okay, and this 7.5 plus this 7.5, you will get the 0. This is the statement minus plus. This is your SSB. Very simple. Very simple. Okay, you have to remember only how to do the calculations. All of you getting? Then next one, BM calculations. BM calculations. How to do the BM calculations? All of you know that how to do the BM calculations. BM calculations. Okay, bending moment at point A is equal to 0. The next point, which is the next point, bending moment at B point. Okay, C point. Sorry. If the movement is at, last lecture we have seen, if the movement is at, then you will get the 2 points for the left and right. Okay, remember that. Bending moment at C point, just left side. Just left side. Okay, how much value you will get? We will check that. Bending moment at just left side. Okay, RA sin 60, this is going clockwise. RA sin 60, 7.5 into distance up to the C point, 3.5 is there, 3.5 is there. Then just left side, check that. There is a 2.5 UDL is given in between A to C. Means this is again going, check that, anti-clockwise direction, anti-clockwise. Okay, up to the C point. We are left to right. Okay, at the C point, bending moment at C point, check that this value is given minus 2.5 into distance up to that, total distance we are converted into the point cloud, and where is that? At the CG. That's why again 3.5 divided by 2. You will get the bending moment at the C point, just left side is 10.95. 10.95 kilonewton meter is there. Okay, kilonewton meter is there. Then after that you have to take the bending moment at C, just right side. You will get the same value, 10.95. Okay, we are coming the just right side, just right side. Then you have to consider again 10.95 is there, and there is a couple is that. You have to consider the couple minus 1.8. Okay, then you will get the, what is the value of that? 9.13 kilonewton meter. This value. Bending moment at C, just right side. Then next is the bending moment at point B. You will get the bending moment at point B. Definitely you will get the 0. Okay. Once you have done the BMD calculations, then draw the BMD diagram. All values we are getting the positive. That's why I will draw here this A point, then C point and B point. To draw this, but here check that this point will get the maximum bending moment. Okay, where is the, in the SSB diagram, there is a sign change, means positive to negative or negative to positive. That point you will get the maximum bending moment. Then we don't know the distance at that point. How to calculate the distance? With the help of, again check that we have seen the similar triangle principle. Okay, we have considered this one triangle and this one triangle. Okay, what is the similar triangle principle? Yes, I will show here how to calculate the maximum bending moment. Remember that. Okay, there is a 7.5 value is there, right? And another one, another end, you have the value. What is the value? 1.25. Consider both value are positive. 1.5 and here is a 7.25 kilonewton value. Okay, we don't know this distance. We'll consider this distance is a distance at a section XX. Okay, a distance. Okay, this distance we don't know. We'll consider the A. What is the total distance? What is the total distance up to that point? 3.5 is there. 3.5. And this total distance is a 3.5 meter. What is the remaining distance? Then this distance is a what? 3.5 minus A, right? 3.5 means total distance minus this distance, you will get this distance. Okay, once you are getting all this value, then you can easily calculate with the help of similar triangle principle. How to calculate? You know the similar triangle principle. A divided by 7.25 is equal to what? This distance 3.5 minus A, 3.5 minus A divided by what? This value 1.25. If you have calculated, then you will get the A is equal to 3 meter. A is equal to 3 meter. Okay, A is equal to 3 meter. This 3 meter will get from point A. From point A. Okay, once you have calculated this A value, this is the 3 meter. Easily you can calculate the maximum bending moment at that section. Okay, then I will take the moment about that section. Bending moment maximum at point XX. At point XX. What is this? RA sin 60. What is the value? 7.5 into this total distance up to the XX point. Okay, bending moment about the section XX, you will get the maximum. This we have calculated the 3 meter. Okay, means here you have to calculate, right? Here you will get the 3 meter, right? Then this you have to consider this UDL up to the 3 meter. Okay, means 2 point. This is going again anti-clockwise direction. 2.5 into what is this distance? 3 meter. 3 meter into 3 by 2 is there. Is equal to, you will get, if you have calculated this value, then you will get the 11.25 kilonewton meter. This is the maximum bending moment. 11.25 kilonewton meter. See, if you have drawn the inclined line in the SSB, then you have to draw the parabolic curve. Okay, second degree parabolic curve. And after that, you will get the 11.25 kilonewton. Then after that, we have calculated the bending moment at the C point left side is 10.95. 10.95, right? 10.95. Means we are coming just downward from this point. Again, we should draw the parabolic curve. 10. What is the value? 95 kilonewton. Then again same point, there is a movement is at. That's why we get the 2 point on the same point, C point. 10.95 minus 1.8, 9.13. We are coming the downward with the help of straight line. 9.13 kilonewton meter is there. Kilonewton meter is there. Okay. Then after that, C to B again UDL is there. Means I can draw the second degree parabolic curve. Second degree parabolic. This is positive. This is your BMD. And this is your SSB. Okay. Here is the important thing is, if you have given the pattern type of load or you have given the roller support in inclined direction, then how to convert it to the vertical direction, also how to convert that paddle type of load into the movement or couple. Remember that. Okay, are you getting how to convert this RA cos 60? We are not using the horizontal value because we don't, they are not told to calculate the thrust diagram. Okay, this is not given in your syllabus. They have given you only the SSB and BMD. If you want to draw the thrust diagram, then we'll use this horizontal value. Okay, today we'll stop here.